What is entropy? Thermodynamics Explained. Have you ever wondered why ice melts or why a hot cup of coffee cools down? These everyday occurrences are linked to a fascinating concept known as entropy. Let's break it down in simple terms. Entropy is a key idea in thermodynamics that measures how disordered or random a system is. It also tells us how much energy in that system cannot be used to do work. This is important because it helps us understand why some processes happen naturally while others do not. To grasp entropy better, think of it as a property of a thermodynamic system that depends solely on its current state. It does not matter how the system reached that state. When energy is transferred as heat at a specific temperature, the entropy of the system changes. If a system absorbs or releases heat in a reversible way, the change in entropy can be calculated using the formula. Change in entropy equals heat transferred divided by temperature. This formula is specific to reversible processes, but remember, entropy itself is a state function. This means its change is consistent, no matter how the process occurs. On a physical level, entropy relates to how energy spreads out. For instance, when heat moves from a hot object to a cold one, the overall entropy of the system increases. This happens because energy becomes more evenly spread out and less available for doing work. That is why entropy is often described as a measure of energy that cannot be used. Looking at it from a microscopic viewpoint, entropy shows how many ways particles in a system can be arranged while still having the same energy. A higher entropy indicates more possible arrangements or greater disorder. Take melting ice as an example. When ice turns into water, its molecules shift from a structured solid state to a more chaotic liquid state, resulting in increased entropy. Entropy also plays a role in spontaneity. According to the second law of thermodynamics, the total entropy of an isolated system usually increases over time. This principle drives natural processes like mixing gases or melting ice. However, just because a process is spontaneous does not mean it happens quickly. Some spontaneous changes can take a long time. In practical terms, understanding entropy helps explain why engines cannot be 100% efficient. Some energy is always lost as heat, which raises the entropy of the surroundings. It also aids in predicting the direction of chemical reactions and equilibrium. Entropy is significant in fields like information theory and cosmology, where it describes disorder or loss of information in various contexts. In essence, entropy is a measure of disorder and energy dispersal in a system. It indicates how much energy is not available for work and governs the direction of natural processes. Understanding entropy is vital for grasping how physical systems behave and the limits of energy use.